Welcome to this session on Venn diagrams. It is an integral part of any aptitude test and tests both the logical and behavioral side of the participants. Venn diagrams are part of set theory, which is of great use in application mathematics. To solve these kinds of questions, we need to have a good grasp of the basics as well as a disciplined approach to drawing figures. Hence, in aptitude parlance, Venn diagram is a systematic diagrammatic representation of sets. The biggest advantage of understanding and mastering set theory for a test taker is that it helps to score in bulk because invariably there are 3 or 4 questions from the same set of data in any Venn diagram question. As mentioned in the previous slide, Venn diagrams are diagrammatic representation of sets. Then, what is a set? A set is a group of elements with a common characteristic or common characteristics. For example, a set of dogs, cats, trees, people, newspapers, etc. A set could be formed with any characteristic that is common to all the elements in that set. Geometric figures like circles, ovals, triangles, rectangles, etc. are used in the representation of sets. For example, a set of politicians can be represented geometrically as a circle or rectangle or square or any other figure. Each geometric figure represents a group or a set. In a combination diagram with 2 or more sets, area common to 2 figures represent elements that are common to the 2 groups. If the groups do not have common members, they will not overlap the diagrams. It would make sense here to recollect all the basics of set theory before we get into Venn diagrams. Please look at the representation in the slide. It is of a set of members in an arts club. It also has some details about the different kinds of people there. Look carefully. The predominant detail given is about the set of people who like music and who like dance. Both of these groups are represented by different ovals. Look carefully at the slide. We're getting into details here. Rectangle represents all the members of the club. This is what we learned as universal set in set theory. Here, the universe is all the members of the club. In the second figure that you see, the red oval represents members who like music, and the blue oval represents members who like dance. What it means is that every member who is represented by the red oval or every member inside the red oval likes music. Similarly, every member inside the blue oval likes dance. In figure 4, the area shaded green represents members who like music but not dance. Please note that it does not include the entire oval. Rather, it avoids the part common to both circles. In figure 5, the area shaded blue represents people who like dance but not music. Both of these are unique people, and these 2 sets represent people who like only music and people who like only dance and will have no common members. Such sets can be named in 2 ways. 1. People who like music but not dance, or 2. People who like music only. Note the representations. These are what will effectively determine your understanding and logic application in Venn diagrams. People tend to ignore these terminologies and then later on regret after the tests are over. This slide is very important. Look at the representation in figure 6, the one in yellow. This is the least understood area in set theory. Here, it would represent people in the club who do not like music or dance. What generally happens is that this area is forgotten because the onus is so much on music and dance and the most important sets in general. This is a cardinal mistake in Venn diagrams. Always remember the spaces which are not in spotlight. The area shaded magenta shown in figure 7 is the most noted area, and it consists of people who like both music and dance. Note that this is the area under both the ovals. Read the question in the slide. Mr. Aman is very fond of pets. He has 45 pets in his house. 5 are dogs, 4 are cats, 8 are rabbits, 6 are squirrels, and the rest are lovebirds. Represent it diagrammatically. How can we represent this? Look at the figure. All the sets have been represented in different shapes: circle, oval, triangle, rectangle, etc. Please note that all the pets are different. There is no element common between the groups, so they do not overlap. Also, note that the sum of all the pets should be 45. Now, let us get into some problem solving using Venn diagrams. Here is when the basic theories that we learned so far are to be applied in order to get some mileage in the test format. Refer the first set of questions Q1 to Q3. Please draw a diagram on your own to incorporate all the data given in the question. In a class of 300 students, 90 play hockey, 130 play football, and 20 play both the games. We are asked to find 1. How many students play only football? 2. How many students do not play any of the two games? 3. How many students play at least one game? In each of these questions, 4 answer choices are also given. Have a look at the diagram. Look at the way in which data has been represented, where the writings are on the figure, the exact place of representations, etc. Look at the first oval. It represents people playing hockey. The entire oval represents that set. So, the number is given outside the oval. Similarly, for the other oval also. Please have a look at the number 300, the total number of students outside the rectangle. That is the universal set. Look at the common set, the set of people who play both the games at 20. Understand the place of representation inside both the ovals in the common place. Now, we have to find out the other areas not given in the data. They have been marked as A, B, and X in the figure. Look carefully. A is the part of the oval which does not include the 20 common elements. The students represented by A play only hockey. We know that the total number of students who play hockey is 90. This 90 includes students who play only hockey, that is A in the diagram and the 20 students who play both hockey and football. So, A plus 20 equals 90. From this, we can find the value of A as 90 minus 20 equals 70. So, the number of students who play only hockey equals 7070. Similarly, B is the set of people who play only football but not hockey. Here also, 20 members of football playing students are not part of that group. We know that the total number of students who play football is 130. This 130 includes students who play only football, given as B in the diagram, and the 20 students who play both football and hockey. Therefore, the value of B will be 130 minus 20, that is equal to 110. X represents the set of people in the school that does not play any of these two games. We know the total number of students is 300. The total number of people playing these games is what? Look at the figure. It is 70 people who play only hockey, 20 who play both the games, and 110 who play only football. So, all of them put together is 200. So, people who do not play any of the two games should be the total of 300 minus 200, that gives 100. That is the number X. Now that we have got all the values, we can answer the questions easily. The answers are given in the slide. Check if you got the answers right. If you did not get the answers, listen to the previous slides once again. Please look at the slide to think of all the potential questions that can come as a part of this question. This would give a complete understanding of the Venn diagram kind of question with two sets on display. Students who play hockey equals 70 plus 20 equals 90. Students who play football equals 110 plus 20 equals 130. Students who play hockey but not football equals 70. Students who play football but not hockey equals 110. Students who play either hockey or football equals 70 plus 20 plus 110, that is equal to 200. What are the things that could have gone wrong? Look at the figure. 1. Marking the value 90 inside the circle will create a confusion with the number inside the common area. Therefore, avoid representing 90 like that. What we mark in area A should be students playing only hockey. Number 2. Similarly, marking 130 inside the football circle is also not correct. What we mark in area B should be students playing only football. 3. We tend to forget about the total number of students and the students who do not play any of the games. That is one area to be careful about. Now, read questions 4 to 6. In a group of 150 people, 55 speak English, 85 speak Telugu, and 30 speak neither English nor Telugu. Question number 4. How many speak both English and Telugu? Question number 5. How many speak only Telugu? Question number 6. How many speak at least one of the two languages? We need to approach this set of questions in the same way as we did with the first set of questions. Look at the diagram. As usual, give special attention to where the numerical values are written with respect to the place. Here, the number of people speaking English is 55 and is represented outside the circle as the entire circle represents the set of people speaking English. The representation should aid that statistic. Therefore, it is represented outside the circle. Similarly, for Telugu at 85 people. Special thing to notice is the representation of the set of people who speak neither Telugu nor English of 30 people. The total set is of 150 people and is the universal set. The whole game in this question is to find out the number of people who speak both Telugu and English. Is it not? Yes. Now, how to find that out? Look at the figure. Take the common area as y. Then, set of people who speak only English equals 55 minus y. The set of people who speak only Telugu equals 85 minus y. Therefore, total is equal to 55 minus y plus 85 minus y plus 30 equals 150. That is, 170 minus y equals 150. Therefore, y equals 20. The number of people who speak both Telugu and English is 20. The other areas to be found out are 1. The set of people who speak only English or the number of people who speak English but not Telugu, and 2. The set of people who speak only Telugu or the set of people who speak Telugu but not English. From observation, if the red circle representing the English-speaking people has 55 elements and a part of it, which is a set of people who speak both languages, is 20, what will the other set of people who speak only English be? It should be 55 minus 20, that is equal to 35. Similarly, number of people who speak only Telugu is 85 minus 20, that is equal to 65. Now, we are done with all calculations and we can answer all questions based out of this question. Look at the answers given as highlighted options in the slide. The answers to questions 4 and 5 are pretty straightforward and are clear from the diagrams. The answer to question number 6 is slightly tricky though. You have to read the question carefully. Here, the question states at least one of the two languages, means the number of people who speak one of these languages plus the number of people who speak both the languages. In this question, it is the number of people who speak English only plus the number of people who speak Telugu only plus the number of people who speak both the languages. The use of such words as at least and at most are very common in these questions, and special care needs to be taken so that mistakes are not made while answering such questions. The basics of set theory are the basis of Venn diagrams. So, it is imperative that those are learned before attempting Venn diagrams. The questions in aptitude tests from Venn diagrams are based on either 2-set or 3-set questions. It means that there will be predominantly 2 or 3 sets from which data needs to be mined for specific purposes. Problems based on 2-set Venn diagrams are discussed in this presentation. Those based on 3 sets are advanced theory applications. The most important mistake that is committed by test takers is ignoring data other than that of the predominant sets. Please pay attention to universal set and the set that is everything except the predominant sets in question. It pays. Finally, if you master the concept of Venn diagrams, it is a bounty because Venn diagram questions always appear in a bunch and therefore advances the chance of success in the examinations a fair bit. I hope you have got a hang of Venn diagrams now. If not, please go through the presentation once again. All the best.